Here's the trap. AI feels like software, but under the hood, it behaves like a factory that charges every time you ask a question.
Exactly. Inference costs money because each prompt triggers real computation on expensive hardware in real time for every user.
So, this is not mostly about building the model once. It is about paying again and again every time the model runs.
Right. Training is the giant upfront cost, but inference is the meter that keeps running. If your app gets popular, inference becomes the business model test.
That is where people get blindsided, right? They prototype a chatbot, it works, users love it, and suddenly, success is what makes it dangerous.
A simple example. Say you build an AI support bot for 10,000 daily users. If each conversation is long, includes company documents, and asks for detailed replies, your compute bill scales with every token processed and generated.
Let's slow that down. What actually drives the cost? Is it tokens, compute, latency, model size, all of it?
The cleanest answer is tokens are the visible meter, but compute is the real resource. Tokens are how much text goes in and out. Compute is the math the model must do for those tokens.
So, when people say token cost, that is basically a convenient wrapper around how much machine work happened.
Yes, but not all tokens are equally cheap in practice. Cost depends on how many tokens, how big the model is, how fast you need the answer, and whether the system has to juggle many users at once.
And that is where model size starts acting like a power law on your budget.
Pretty much. Bigger models have more parameters, which means more numerical operations per token. More operations means more accelerator time, more memory pressure, more energy, and fewer users served per machine.
Give me a concrete contrast.
Imagine two apps that both answer coding questions. One uses a smaller model and gives solid, short answers. The other uses a much larger model and writes long, nuanced responses. Even if both handle the same user count, the larger model may need far more hardware time for each reply.
So, a better answer is not free. More intelligence often means more math.
Exactly. There is usually a trade-off among quality, speed, and cost. Teams that ignore that trade-off can ship a product people love, but cannot afford to keep online.
And tokens cut both ways. It is not just the answer length. The input matters too.
A lot. If you stuff the prompt with a giant chat history, pasted logs, retrieved documents, tool results, and strict formatting instructions, the model has to read all of that before it can answer.
So, the hidden killer is context bloat.
Yes. Picture a code assistant in an IDE. If it sends the entire file, the previous conversation, stack traces, and 5 documentation chunks for every request, the user may only ask, "Why is this null?" But the system is paying to process a small novel.
That creates a weird strategic divide. The winner is not just the company with the smartest model, it is the one that uses intelligence efficiently.
That is a big shift. Good AI products are often systems engineering products. Prompt design, retrieval quality, caching, truncation, routing, batching, and choosing the right model tier all change the unit economics.
Let's hit latency, because programmers feel that immediately. Why does faster usually cost more?
Because low latency means keeping more compute ready and under less contention. If you want quick responses during peak traffic, you need spare capacity. Spare capacity is expensive, but users punish slow systems.
So, now the stakes are not abstract. If your app stalls, users leave. If you over-provision, margins vanish.
Right. Think about an AI meeting assistant that summarizes calls live. It cannot wait 30 seconds after every speaker turn. Real-time behavior forces you to pay for responsiveness, not just raw token throughput.
What is the practical lesson for a programmer building their first AI feature?
Treat every token like a design choice. Keep prompts tight. Send only the context that matters. Cap verbose outputs. And do not use a larger model unless the task truly needs it.
So before asking, what can the model do? Ask, what does this interaction cost at scale?
Exactly. Inference cost is the price of turning intelligence into a live service. The teams that win are not the ones generating the most tokens. They are the ones generating the most value per token.